Alright, so in this video, I'm going to be solving the problem 200 squared minus 199 squared. And to solve this problem, I actually have three different methods. So make sure to stick for all three of the methods to find out which one is the best one for you. So for method number one, what I'm going to do is rewrite 200 squared as 199 plus 1 squared. So now I have 199 plus 1 squared minus 199 squared. And if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. Now this means that 199 plus 1 squared, this should equal 199 squared plus 2 times 199 times 1 plus 1 squared. And this is equal to 199 squared plus 398 plus 1, which is equal to 199 squared plus 399. So this means that 200 squared minus 199 squared is equal to, well, this right here is 200 squared. So 199 squared plus 139. And now I have this minus 199 squared. So 199 squared and negative 199 squared, these two cancel out. And all I'm left with is 139. Or sorry, this is actually 399. So then these two cancel out, and I'm left with 399. So this is my answer. Now for method number two, my problem was 200 squared minus 199 squared. And now for this method, what I'm going to do is rewrite 199 squared as 200 minus 1 squared. So in our first method, we wrote 200 squared as 199 plus 1 squared. This time we're going to rewrite 199 squared as 200 minus 1 squared. So now, if I have something in the form a minus b squared, this is equal to a squared minus 2ab plus b squared. So 200 minus 1 squared is equal to 200 squared minus 2 times 200 times 1 plus 1 squared. And now this is equal to 200 squared minus 400 plus 1, which is equal to 200 squared minus 399. So this is the value of 199 squared. So 200 squared minus 199 squared is going to equal 200 squared minus 200 squared minus 399, which is equal to 200 squared minus 200 squared plus 399. So then these two cancel out, and then this is equal to 399. So that is my second method. And now finally for method number three, I have 200 squared minus 199 squared. And I know from methods 1 and 2, what I did was I rewrote either one of these, but now I'm simply going to just use a property that says a squared minus b squared is equal to a plus b times a minus b. And I'm going to use this property on here. So this means that I get 200 plus 199 times 200 minus 199. 200 plus 199 is 399, and 200 minus 199 is simply 1. So I get 399 times 1, which is just 399. And as you can see, this is probably the most efficient out of the three methods because I've solved it the fastest. So whenever you see something in the form a number squared minus another number squared, always use this property because it's really helpful to solving the problem fast. Alright, so in this video, I'm going to be solving a system of equations. So in my system of equations, I have two equations. My first is AB plus A is equal to 32. So this is going to be my first equation. And my second equation is going to be AB plus B is equal to 35. So to solve this system of equations, I have to find the value of A and B. So to start out, what I'm going to do is subtract equation 2 from equation 1. So equation 1 minus equation 2. Equation 1 is AB plus A equals 32. So I have AB plus A minus AB plus B is equal to 32 minus 35. So to solve this, what I'm first going to do is distribute the negative sign. So now I get AB plus A minus AB minus B is equal to 32 minus 5, which is equal to negative 3. Now I can cancel out AB and negative AB, so I'm left with A minus B is equal to negative 3. And this means that A is equal to B minus 3. So now what I can do is substitute this value of A into equation number 2. So equation number 2 is AB plus B equals 35, right? Well, now that I've got a value of A in correlation to the value of B, I can plug this in. So now I get B minus 3 times B plus B is equal to 35. And now my only variable in this equation is B. So we can solve this. What I'm first going to do is distribute the B. B times B is B squared, and B times negative 3 is negative 3B. Now I have this plus B, which is equal to 35. And negative 3B plus B is equal to negative 2B. And if I subtract 35 on both sides, I get B squared minus 2B minus 35 is equal to 0. Now from here, what I'm going to do is actually add this back because we did miss a step. So B squared minus 2B is equal to 35 once again. Actually, before doing that, what I'm going to do is add 1 on both sides. So now I have B squared minus 2B plus 1 is equal to 36. And now the reason I did that is because B squared minus 2B plus 1 is the same thing as B minus 1 squared. And now I can take the square root on both sides because the square root of 36 is a whole number. And now I get B minus 1 is equal to positive or negative 6. So this gives me two equations. I get B minus 1 is equal to positive 6, and B minus 1 is equal to negative 6. So for B minus 1 equals positive 6, I can just add 1 on both sides, and I get B equals 7. And for b minus 1 equals negative 6, I can again add 1 on both sides, and I get b equals negative 5. So now from here, I have to plug this back into this equation right here, ab plus b equals 35. So if b equals 7, I get 7a plus 7 is equal to 35, meaning 7a is equal to 28, and a equals 4. So if a equals 4, then b equals 7. This is one solution to my system equations. And now if b equals negative 5, I get negative 5a minus 5 is equal to 35, meaning negative 5a is equal to 40, and a equals negative 8. So if b equals negative 5, then a equals negative 8. So these are my two solutions.